Hi guys, today we're going to be doing a limiting reagent problem. So our problem is if 4.95 grams of C2H4 are combusted with 3.25 grams of oxygen, what's the limiting reagent and how many grams of CO2 is formed? So our step one is going to be to write out and balance our equation. So from the problem we start with C2H4 and it combusts with oxygen, and since oxygen is diatomic, it's O2, and then from our combustion, we know that it will always yield CO2 and H2O. And then we just want to balance our equation. So we see that on the left side we have two C's, so on the right side we want two C's. And then on the left side we have four H's, and so we're going to need another 2 in front of our water. And then we'll count up our O's. So from CO2 we have 4 O's, and from H2O we have 2. So we want 6 O's on the left side, and since we already have 2, we just need a coefficient of 3, and then we just double check that our equation is all balanced so that we have the right mole ratios and the right coefficients. And then since we're looking for limiting reagent, which we can tell because we're given both the grams of both of the reactants, we're gonna choose one reactant and write it all the way out to see how much of the product it can make, and then do the same with the other reactant and see which one makes less, and we'll note that one is our limiting reagent, and then we'll also figure out from that how many grams of CO2 we can make. So our step 2 is going to be to start with one of the reactants. I'm going to choose C2H4 because that's the one they give us first, and then we're just going to start with the grams that they give us. So in the problem, we know that we have 4.95 grams of C2H4. And then we're going to put 1 mole on top, and we're going to use the molar mass to cancel out grams on the bottom. So we're just going to scroll down here and look, and we see that carbon has 12 grams per mole, and we have 2 of those, and then hydrogen has 1.01 about grams per mole, and so we'll just add that together. And you should end up with 28.04 grams. And now we want moles of C2H4 to cancel on the bottom. And since there's no coefficient here in front of C2H4, it's just going to be 1 mole C2H4. But since we're looking for CO2, CO2 does have a coefficient. When we balanced it, we put that 2 in front. So we want to make sure that we put that 2 mole CO2 on the top. And then we are looking for grams, so we'll put 1 mole of CO2 on the bottom. And we'll put the molar mass on top, so we're just going to scroll back down. And we see that carbon's 12 again, and oxygen is about 16, and we have 2 oxygens. And so that's about 44 grams CO2. So now let's just double check that our units and everything cancel. So here we have grams, and that cancels with this grams, and here we have moles, and that cancels that moles, and here we have moles, and that cancels this moles, and then we're left with grams, which is what we want. So now we're just going to plug it into our calculator. So I'm going to do 4.95 times 2, I'm just going to skip over that one, times 44, and then I'm going to get that number, which comes to 435.6, and I'm going to divide it by 28.04, and then I end up with 15.53 grams. So now our step 3 is going to be to do the same thing with our other reactant, which in this case is oxygen. So from the problem, I know that I start with 3.25 grams of oxygen, and then I'll put that over 1, and we'll just follow the same steps. So we're going to do 1 mole of O2 over the molar mass, and we'll go back down here and look at our table and see that oxygen's about 16, and we have 2 of them, so that's just going to be 32 grams of O2. And then we're going to do our mole ratio again. Oxygen does have a coefficient, so we want to make sure we get that 3 mole of O2 in there, and then our 2 mole of CO2 in there. And then we can use the same numbers from this equation because the molar mass of CO2 hasn't changed. So we'll make sure that we get that 44 grams of CO2 over the 1 mole of CO2. And we'll double check that all of our units cancel again. So here we have grams, that cancels with this grams. Here we have moles, that cancels with this moles. Here we have moles, that cancels with this moles. And we're left with grams, which is perfect. So now for this one, I'm going to do the same thing. I'm going to do 3.25 times 2 times 44. And then I'm going to do 32 times 3, which comes to 96. And so I've got the top numbers, which equals 286 divided by 96. And I get 2.9 8 grams. Okay, so since we see that we obviously make less when we start with oxygen, that's going to be our limiting reagent, because there's no way for us to make more than that because we don't have enough oxygen to make the CO2. So we know that O2 is limiting because of, we don't have enough of it to make the full amount that we could make with the C2H4. And we know that since O2 is limiting and we already went through the whole reaction, we can only make 2.98 grams of CO2. So that's how you want to do a limiting reagent problem. Just make sure that you balance your equation correctly and you don't forget to use those mole ratios in your problem, and that you see which one makes less, and that's how you'll know which one is the limiting reagent. Have a great day.